Okay, I want to go over some quiz kind of corrections, things that I saw in there that I didn't like that hopefully we can get straightened out. This right here up above I wrote is the parent function or the basic equation of exponential growth or decay. Where up in the exponent spot we've got this value of h and this value of k, and h is going to be either you go to the right so many units or you go to the left so many units. Okay, the k value is going to tell you if you go up so many units and if you go down so many units. Now h you got to compare with that x minus h, and it's got to be up in the exponent spot. So my function down here, I've got x minus 3, so x minus h, that means that h is 3. So that means that I'm going to move over to the right 3 because it's really a positive 3. Okay, and then this bigger number that's not in the exponent spot that kind of gets dropped down is your k value, and since it's a minus 5, I'm going to go down 5. So over on my graph paper, I'm going to go to the right 3, I'm going to go down 5, and this here, maybe better ink on my graph paper right there, that is my new origin. Okay. It's not going to be my vertex. It's not going to be a point of my exponential function. It's just literally the spot that I'm going to count to the left and to the right and up and down when I get my ordered pairs. Okay, now the other thing I caught was a lot of you are trying to make your table, and you're picking the right numbers, -1, -2, 0, 1, and 2 for x, but you're not identifying the parent function. So this is the guy that you want to make the table for. Okay, we've already taken care of the -3 in the exponent spot and -5 by coming up with this new origin right here. So now I want to take 3 to the second power and get 9. And -2, 3 to the -2 is just a reciprocal of that, so 1/9. Okay, 3 to the first power, which is 3. 3 to the negative first power, which is 1/3. And anything to the 0 power is always 1. Where this 2 comes into play, just like every single parent function relationship we've ever done, is that I'm going to multiply whatever you put here in your parent function by 2. So times 2, times 2, times 2, times 2, times 2. So 18, 6, 2, 2/3, 2 9s. So my ordered pair would look like -2, 2 9s, -1, 2/3, and you can go all the way through those. I guess I'll do it 0, 2, 1, 6, and then 2, 18. But they're all going to be plotted from my new origin. So from here, -2 over to the right 2 and up just a little bit, -1 and 2/3, 0 and 2, 1 and 1, 2, 3, 4, 5, 6. Notice I'm counting from my new origin, and over 2 and up 18, which isn't going to show up in my graph. It's going to be way up there. So I'm going to start off small, and I'm going to grow really quick because this is exponential growth. Because my base was 3. Now, my domain, I had no problems with any numbers I put into my table, so x is all real numbers. My range, see, these asymptotes, it used to be that it was the x-axis, but it just moved down 3. So here's that asymptote. My range is bigger than that asymptote, so y is going to be greater than -5. Kind of like when we moved the parabola up and down, that bottom number was your range. In parabolas, there's an equals, but now we're not actually touching that dashed line at y equals 5. And then you've got this asymptote at y is equal to -5. And again, to refresh your memory, asymptote is line that it doesn't quite touch. So hopefully this helps out. Again, your table is only for the parent function here, not with the 2, not the 3, and the 5 that are over there. The movement left to right, up and down. Hopefully this helps out. I just noticed that the tables were a little bit out of whack. And I think maybe being able to use your calculator helped out with you messing it all up. So, all right. See you guys hopefully tomorrow.